Hi everyone, I'm Chris Lee, founder of Ava Protocol. Today, I'm very excited to show you a developer demo of our EigenLayer AVS API. In this demo, I will walk you through how to perform an EVM smart contract automation with Ava Protocol AVS. This demo will be performed on Ethereum mainnet. As you can see on the screen at validator.info, there are currently 24 EigenLayer operators running our AVS network. Our AVS has two main components. The aggregator, which is currently running at the top of the command line on my screen. It handles smart contract execution and distributes tasks to the operators. The operators at the bottom of the command line are responsible for executing the assigned tasks. In this demo, I'm using a Node.js CLI script to interact with our AVS API and schedule an automated task. The script is already configured to connect to Ethereum mainnet and our deployed smart contracts. Next, we'll take a look at the smart wallets, or account abstraction, a key component on Ethereum that made our trustless automation solution possible. In this command line response, you'll notice that this smart wallet address is already created and associated with my EOA wallet. The wallet's contract is generated through a ERC4337 factory contract. When a new user interacts with our app, the first time they register a task, we will ask them to create and deploy a smart wallet. In the next step, we will demo creating a task with a user-specified condition. I want to set up an automation where when the token price exceeds a certain threshold, an action is triggered, transferring 12 ERC20 tokens from my smart wallet to my EOA wallet address. For demo purpose, we will set up a smart contract similar to Chainlink's price oracle contract, allowing us to simulate the price changes from an oracle to trigger the action. Now, let's return to the command line where we'll schedule this task from the CLI. Once scheduled, you'll see that the task ID is 7. When we query task ID 7, we'll get detailed task information. This acts as your intent stored in our AVS network. You can also observe that the task ID 7 is active. The operators will execute the task once its conditions are met, which in this case is when the token price exceeds a certain threshold. Currently, the conditions have not been met. To simulate triggering the task, we'll update our oracle's price to exceed the threshold. As you can see, the task has now been triggered and executed because the conditions has been met. The operators process the tasks, and if we check task ID 7 again, you'll see it has changed to completed. And the ERC20 tokens have been transferred. This transaction from the demo can easily be verified on etherscan.io. As seen, my smart wallet has successfully transferred 12 tokens to the target wallet address. Now let's look at some failure cases. If a task fails, we can inspect each step from the command line's task details and check out the reason for failure. Let's also try canceling a task. The task ID 6 is still active, so we'll go ahead and cancel it. Once canceled, The task list response will show a canceled status for task ID 6. Now, let's go over how we make this automation flow work with any Ethereum smart contract. We achieve this by first generating the call data for the smart contract call. Checking out our demo's task details, you'll notice a smart contract call data included. Here's how we generated the long string of the call data. It comes from the smart contracts API, specifically the function we're calling. We don't need the entire API, just the relevant part of this function. By using this API and providing the values for the method's parameters, we can generate the correct call data for the smart contract call. Lastly, let's compare our demo process with a real-world scenario, such as triggering a swap on the MetaMask router smart contract. Similar to the demo, as long as we know the destination smart contract's address and its API, we can generate the method call data and store the intent. Eventually, our operators will trigger and execute the smart contract call. That wraps up today's video. Thank you for watching this developer demo of our EigenLayer AVS API. Be sure to follow us on Twitter and explore our developer documentation for more details. Thank you.